Hey, so today I'd like to create a nice visualization of a vector in Unity, but I would like to do it a little differently than I've seen online before. Some places they might point you to the onGUI function and have you put some commands in there, but that's not very flexible and doesn't work all that well when you're actually playing a game and you want to see the vectors that you're drawing. So what I'm going to do is create a special folder and use a different way to kind of load an asset. So I'm in Unity, and I have imported this arrow 3D model. This you can find on Brightspace in our materials section, and something I don't really like about this model, it needs to be fixed. If you compare it to the shell model, they're pointing in opposite directions because the arrow is pointing in the negative Z, and that's not really cool. We'll have to work around that. So, anyway, I'd like to create a prefab. So let me create an empty game object, and let me just call it vector, and drop that arrow right on there. And so this is going to be the prefab that I instantiate in order to make a vector show up. The arrow, once I drag it on there, the scale is kind of crazy. I'm just going to set these all to 1s. Then you can see it a little. Alright, you'll see it better when it's a prefab. So let me go back to my project panel, and I don't want to put it in my prefabs folder right now. I want to put it actually in a special folder called resources with a capital R. Now what's special about this folder is that anything in it will be picked up and recognized by Unity as something you can access at runtime. So not just in the editor, but we can write code that loads files from this resources folder. So let me open that up, drag my vector object in there, and then delete the one from my scene. So now I have this prefab, and I can take a look at that prefab a little more closely. Let's see. Alright, I could just center it and everything, make it look a little nicer, adjust some of these properties. Let's see, a little narrower, a lot flatter. That looks a lot better. Alright, so when I look at these, the one that controls the length of it is Z. So I'm going to be adjusting Z when I try to visualize this using different lengths. Okay. Alright, so now I want to make a script. So let me go back to my scripts folder. Alright, here I'm going to make a new C# script called VectorVisualizer, and open that up. Alright, so this file is going to be representing a vector. So I need some variables. Let's say a position where it's going to be based, and I'll start it off at the origin, vector3.0. And then we'll also need something to represent the vector. A decent starting vector might be vector3.forward. And then I'll also want a reference to our prefab. I'll call it arrow. Okay, so the first thing we want to do is get a reference to our prefab. Game object prefab, and so this prefab, we're going to instantiate it, and we're going to store that object in this arrow variable. So prefab we're going to need to get from the resources folder. This special resources folder can be accessed through the resources class, resources.load, and then you have to specify what type of asset it's going to be. In this case, a prefab will be loaded as just a plain game object, so that's pretty easy. And then I have to tell it the name of that. Mine is organized just in the resources folder, and it's called vector with a capital V. When you specify it as a resource, you specify it the way you see it in Unity, where it doesn't have a file extension. So I'm just going to say vector. If it was in a subfolder, I'd say like my folder / / and then the name. Alright, so we load the asset, and then we can instantiate it. Let's use the position variable that we decided on, and for the rotation, just the identity quaternion. And then I'm gonna want to set up another function, a function that we could use anytime if we had a vector visualizer to be able to change how the arrow looks, its position and its rotation. So let's call that function. Let's make it public so it's accessible anywhere. Let's call it set. So I'm going to provide a vector3 new position and a vector3 new vector. And then here I want to set my position to be the new position, my vector to be the new vector, and then I want to update the arrow. So there's a chance that the arrow hasn't been loaded yet, so let me say if arrow is null, then we'll just return, but otherwise we can do arrow.transform.position, set it to position, and we'll also want to use the new vector that we got stored in vector to point in the right direction and to have the right length. So if it has 0 length or really small length, maybe we'll just leave it alone. So let's say if vector.magnitude is less than, or let's say if it's greater than some small value, then we'll go along and keep changing things. Now here we want the arrow to point in that direction, the direction of that vector. So the arrow is a game object that has a transform, arrow.transform. Let's say, what is it, rotation. Let's use quaternion.look rotation. And so we'll specify the forward direction, which will be the same direction as the vector we're trying to reproduce here. But it has to be normalized. It has to be a unit vector, the direction that we're looking. When we've got that, then we want to use the length of the vector to determine the scale of this 3D arrow model. So let me make a scale vector. It's a vector 3 because you can scale in X, Y, and Z dimensions. And we really just want to scale in the Z direction and kind of keep the other ones the same. So I'm going to set this scale equal to the arrows, arrow.transform.local scale. So that's its normal scale, what it's starting off at. Then I'm going to modify it a little bit. The scale.z is going to be the vector.magnitude. So all of the length of the vector is going to go into the z direction. And then I have to do that workaround I mentioned. It's pointing in the wrong direction, so I'll make this negative. Alright, but if you were using a better 3D model, you wouldn't need that. And then I want to do arrow.transform.local scale and set it to scale. Right. So that looks pretty good. And now I want to use that set function in my start. So set using our stored position and vector. Cool. So the way this script now will work is that it is a mono behavior. It means it's a type of component. We can add this component at any time at runtime, and it'll load the resource and set it all up so that it'll make that arrow point in the direction that it's supposed to. So let me try it. Let me first try it with, let's do something simple. So let me make a game object. I'll call it vector tester. And let me also make a new script for that vector tester. Vector tester. Okay. So this vector tester, I would like it to use my visualizer and just create a vector, whatever I tell it to, that I can see. So let me say vector visualizer. This is going to be the type of this thing, viz. So what I'd like is to attach a new component of this type to whatever game object the vector tester is. So game object dot add component. Add a component of type vector visualizer, and then store it in this reference, viz. Then I can do viz dot set. I'll need a position, so let's just do vector 3.0, the origin. And then we'll need a new vector. A new vector we could construct from any old thing, so I could even test out some of our vector methods. Vector 3a, let's say it's 0, 0, 1, so it's like pointing along the positive z-axis, and then maybe vector 3b is pointing along the x-axis. And then we could do a visualization of vector 3 dot cross a comma b. So what does the cross product look like when you cross the z direction with the x direction? Let's find out. Okay. So I will have to put the vector tester script onto that object and then check it out. Alright, so there's my vector standing up over there. It's saying that when I cross the positive z, let's see, let me try to pause it when it's running. Okay, so we've got positive z going this way. If I cross positive z with positive x, I get positive y. That's the direction it's pointing. That's cool. That checks out. Alright, I could try other stuff too. I could say, like, I don't know, what's when I take a unit vector and some other, I could use the dot product between those two vectors. And if you remember, dot product returns a float, not a vector, so it's just a number. But I could scale another vector by this value. So if I had like a times that dot product is going to take the unit vector pointing in the z direction and scale it according to the dot product of these two. And actually I think this isn't going to be a good one because they are perpendicular vectors. So let me put some values in here. Yeah, it maybe won't show up all that well, but it shows you what you can do with it. You can put in any vector and then see what its result is. So this is stretched 7 units in the z direction. Okay, and then for one last try, let me put this into my player controller so that the tank can show maybe a vector for the direction it's going. So I'll need to add this component, and I'll need to set according to the velocity of the tank. Alright. So I'll need to do a GameObject.add component VectorVisualizer, and I want to store this in a variable to be used later, which means I need a reference to it outside of this start function. So let me make a reference to a vector visualizer, and then I'll use that here. Okay, got that part of it, and now I need to find a place, let's say in update. So update will happen every time that this needs to show up on the screen, so this should be a good place for it. Viz.set. So give it a position, so transform.position, so it stays following the tank, and then the new vector value should be rb.velocity. There we go. Alright, cool. So every direction I go, and then it's going to point, and the faster I go, the longer the arrow. Cool. Works pretty well. So it's cool to see our vectors in action. This is just one way to visualize them that I thought was kind of fun, and it gives us a little peek into this resource system where we can load assets at runtime using scripts. If you'll notice, I didn't have to assign any references in the editor because I was loading those assets directly through code. It was pretty handy. So it made setting things up super easy. I just had to add the components to things and call one function, and then it was all good. So I hope you like that, and I hope you try it out and try to see what other math we've been doing with vectors that you can visualize in your game. See ya.